Okay. Uh, Chemistry. All right. I'm going to be teaching the mole concept today. Mole concept stroke stochiometry. All right. And there's no point for too much analysis here. The mole, we know, mole is just the number of carbon 12 the mole is just the number of carbon 12 atoms, okay? You understand? That's present in one molecule of a substance. All right, but you don't need to stress yourself about it. All right. There are many ways to quantify matter. Do you understand? There are many ways to quantify matter. All right. The number one way to quantify matter we know is mass. Okay, we know is mass, and then we have the volume. Okay, and then we have the mole. All right. Later on, we are going to talk about the number of substances. All right. Later, we are going to talk about the number of substances. All right. But let's start with the mass. Okay. The mass is just the amount in gram of a substance. Do you get it? All right. What is it? Okay. The mole is the number of what? Is the number of the mass. Sorry. We are going to be starting with what? With the mass. Okay. The mass is the amount in gram of a substance. Do you understand? Is the amount in gram of a substance. Okay. Like if I pick some grain of sand now, okay, do you understand? That grain of sand has a mass, okay? Do you understand? So which is not new, all right? It has a mass, all right? So in more concept of stoichiometry, we are talking about the amount of substances, okay, they are reacting. Do you understand? Like if I have like 5 grams of substance A now, if I have like 5 grams of substance A, that 5 grams of substance A has and it's to react with what? With substance B. Do you understand? Okay, that 5 grams of substance A, there's a mass of substance B. Do you understand? That is required to react with this 5 grams of what? Substance A. Do you understand? And when that 5 grams of substance A reacts with the mass of substance B that it can react with, there's an amount of what? The products in terms of mass or volume or moles that can be formed, that will be formed. Do you understand? So in stoichiometry or in mole concept, what we do is that what? We study the amount. If we have 5 grams of one substance now, one reactant, what mass or what number of moles or what volume of the other reactants is required to react with this particular given mass of this reactant. Do you understand? Like for example, now if A and B are reactants, do you understand? There's an amount of B that will react with A. So in stoichiometry, we are studying how we can predict the number of what? The substances. Are you getting it? That will react. Do you get it? All right. So if we have 5 grams of A now, what mass of B will react with this? Do you understand? Apart from experimentation, we can use calculation to get it. Do you understand? And that's what we do in mole concept. Am I communicating? Do you understand? Quickly, let's get on to it. It's very simple. So let's say, for example, now we have a reaction like you are distracting. What's the problem? Let's say we have a reactant like A. Okay, like let me say sodium chloride reacting with what? With CuSO4. Okay, to produce Na2SO4 plus CuCl2. So let's try to balance the equation. All right, sodium here is 1. Let's put 2 so that it can balance with 2 here. Do you understand? And chlorine is now 2. Is it not? Chlorine is 2 here, balance. Copper is 1 here. Copper is 1 here, balance. Sulfur is 1 here. Sulfur is 1 here, balance. Oxygen is 4 here. Oxygen is 4 here, balance. It's balanced now. All right. So if I have a mass of sodium chloride, okay, there's an amount of what? of copper 2 sulfates that will react completely with what? With this mass of what? Sodium chloride that I have. Do you understand? Do you get it? And there is an amount of what? There's a mass of sodium trisulfate, trisulfate 6, okay, that is required to react completely. That will be produced as a result of this reaction. And also there's a mass of this that will produce. Do you understand? And this we can obtain it not only by experimenting. You understand? That's why we use this mass of this now. Okay, we add CuSO4 to it. Do you get it? After adding CuSO4 to it, okay, we'll find out that there's a when we later find out the mass of this CuSO4 that will react with what? This NaCl. Do you understand? We measure it. Am I communicating? And then we now measure the mass of what? Of Na2SO4 and CuCl2. By experimentation we can get it, but first that experimentation is a bit what? Complicated. It's a bit technical. Why is it technical? Because we will have to find a way to separate between these two before we can measure them. Do you understand? That's why the calculation method is very efficient. Do you understand? And very good. Do you get it? So we'll start with this. How do we answer questions? How do we obtain the mass? For example, if they give us the mass of this now, okay, NaCl, how do we know the mass of this that will react completely with that NaCl? And how do we now know the mass of what? The products that will be formed? Am I communicating? And that is what we are doing in stoichiometry. Am I communicating at all? You understand? So in stoichiometry, for example, all right, in stoichiometry or in mole concept, all right, we are given what? Mass. All right, in every stoichiometric question in WAEC, JAM, NECO, or whatever, okay, there are two things we are looking out for in every stoichiometric question. In any question that involves what? The mass of substance. Are you getting it? Okay, or number of moles. Whether it involves mass of a substance, or number of moles of a substance, or volume of a substance, or the number of substances, as the case may be, of a substance, there are two things we are looking out for. Am I communicating? The two things that we are looking out for. Number one thing we are looking out for is one of them they give the one that they gave us something about. Am I communicating? So if they give us something about one thing, you understand? We are looking out for that one. Do you get it? Then the other one we are looking out for is what? Is what they ask us to look for something about. You understand? Those are the things. The first one is what? You are giving something about it. The second one is that what? You have to look for something about it. Am I communicating? Now in the question they might mention all the substance in the what? In the chemical equation, because in all stoichiometric equation they will always give you what? The equation of reaction. I can say now in that question they might mention all the substance in that equation of reaction, or they might mention maybe 3. Do you understand? But out of that 3, there are 2 things you are looking out for. The first thing you are looking out for is that what? You are giving something about it. You understand? You are giving something about it. Then the second thing you are looking out for is that you are asked to look for something about it. You might be given the mass of one substance, then you have to look for the mass of the other substance. That means you are looking out for those 2 substances. One, just take note, you are giving one something about it. The other one, you have to look for something about it. I hope I'm making sense. Do you understand? So, for example, they might give you the mass of sodium chloride. They will now tell you to find the mass of what? Na2SO4. That means you are relating what? NaCl and what? And Na2SO4. Whether they mentioned all these substances or not, it doesn't concern you. Your concern is that what? You are given one thing and then you are asked to look for what? For the other. Am I communicating? So when they mention these 4 things now, for example, if they mention like this, this, and this, are you getting it? Your own concern is 2 out of those 3 that they mentioned. So if they give you the mass of this and they and they ask you to look for the mass of this, okay, even if they mention these 3, your concern is not in this one. This one does not concern you, because why? They neither told you to look for something about this, neither did they tell you to to find something about this. Do you understand? So your own aim now is to is to relate this to this. Do you understand? Because you use what you have to get what you want. I hope I'm making sense. You understand? So you just have to look at the question, then filter through it. Filter it very well. Look for what you are looking out for. Those 2 things, select it, bring it out, and then use what you have now to get what you want. You understand? So if they give me number of moles of this now, they say I should find the mass of this. That means whatever they mention does not concern me. The only 2 things I'm looking out for is this. I'll use what I have for these two things to get what I'm looking for. Do you understand? If they give us, they might give us number of moles of one, find the number of moles of the other. They might give you mass of one, find the mass of the other. They might give you mass of one, find the number of moles of the other. Or they give you number of moles of one, they say find the mass of the other. All you just have to do is relate what you have to what you are looking for. That is how you solve. That is the trick there. I'm going to do some examples now. For example, now here they said that if we ask a question here, and they said find the mass of copper 2 chloride required to react completely. Sorry, find the mass of copper 2 chloride, okay, that would be produced when 25 grams of sodium chloride reacts completely with what? With copper 2 sulfate. Are you following? Okay, they said we should find the mass of copper 2 chloride that would be produced when 25 grams of sodium chloride reacts completely with what? Copper 2 sulfate. Now you see that in this equation now, they gave three things, right? They mentioned copper 2 chloride, they mentioned sodium chloride, and they mentioned copper 2 sulfate. Am I communicating? Now, just like I've always said, that you are looking out for what? For just two things. Just two things. You are looking out for just two things. The first one, you are giving something about it. The second one, you are asked to look for something about it. Now, let's go over the question. Find the mass of copper 2 chloride. Find the mass of copper 2 chloride. Okay? Find the mass of copper. That means you have to look for something about what? Copper 2 chloride. Am I communicating? You understand? You have to look for something about copper 2, that is the mass. You are looking for the mass of copper 2 chloride. So copper 2 chloride is one of the substances you are looking out for. CuCl2. Am I communicating? Required to react completely with what? That will be produced, right? When, of course, that will be produced because copper 2 chloride is what? Is one of the products, right? Copper 2 chloride is one of the products, so that will be produced. That will be produced when 25 grams of sodium chloride. When 25 grams, they gave you something about sodium chloride, right? Which is the mass of sodium chloride. Why do we know its mass? How do we know its mass? What is this gram? Are you following? So 25 grams of sodium chloride reacts completely with copper 2 sulfates. So that means the two things we are looking at for is this and what? And sodium chloride, because they asked us to look for something about it and they gave us something about sodium chloride. So sodium chloride is the other substance we are looking out for. Do you understand? Then the next thing is, what are we considering copper 2 chloride? Is what? It's mass, right? So they asked us to look for the mass of copper 2 chloride. So mass is what we are considering. Okay? Now they gave us something about sodium chloride. That is what? The mass, right? So we are still considering what? The mass. Are you following? Then the next thing to do is what? Is the yes. They ask us to look for the mass of copper 2 chloride, right? You put that one as X. Are you following? Then they gave us something about sodium chloride, right? Which is what? 25 grams, right? 25 grams. So the first thing you put here is what? Is what you have in the question. Are you getting it? In the question, they ask you to look for what? For copper 2 chloride. That's why you present it as X. It's an unknown. Then the other one was, they gave you what? Something about it, which is what? 25 grams. Do you understand? Do you get it? So the next thing now is what? Is to look at the standard relationship. Are you getting it? Now, the standard relationship, you get it from the equation. According to the equation, what is the mass of copper 2 chloride? Of course, in brackets, they will give you the relative atomic mass of each of the elements. Are you getting it? The relative atomic mass of for Yes, they'll give you Na equal to what, 23, Cl equal to what, 35.5, Cu equal to 63.5 or 64. They normally put it as 63. Let me put 64. Let me use 64. Then S is what, 32. O is what, 16. So that is what they'll give you. So you now check according to the equation. Okay, what is the mass of NaC? Since we are having CuCl2 and we are considering mass, so we are going to check according to the equation what is the mass of CuCl2. Are you following? Do you understand? What is the mass of CuCl2 according to the equation? So we just put CuCl2, of course, CuCl2. Cu is what, 64, right? Plus Cl2, that is 35.5 times 2, right? That will be 64 plus what? Plus 35.5 times 2 will give us what? 71, right? So if you add everything together, it gives us 135, right? Gram. Is it not? So according to the equation, we have CuCl2 here, right? That means we have what? 135 here. So we have 135 gram here. Are you following? Now, according to the equation again, since we are considering mass of NaCl, what is the mass of NaCl according to the equation? That will be 2 times, right? NaCl, right? So NaCl is what? NaCl is 23. This is 2 times, right? That is 2 NaCl, right? 2 times Na is what? 23, right? 23 plus 35.5. Is it not? That will be 2 times what? 23 plus 35.5, that is what? 58.5, right? Right? 2 times 58.5, that will give you 117, right? 117 gram. So we have what? 117 gram here. See that? Now, this is what they are trying to ask you. According to the equation, we have what? 135 gram of CuCl2, right? And this. Now, in the equation, sodium chloride reacts with what? Copper 2 sulfates, right? To produce what? Sodium sulfate and what? Copper 2 chloride. Am I communicating? So they are trying to ask you, look at what they are trying to ask you here. If that 135 gram of what? Copper 2 chloride reacts completely with what? If 135 gram of copper 2 chloride is produced, are you getting it? When 117 gram of sodium chloride reacts completely with what? CuSO4. Are you getting it? What will be the mass of copper 2 chloride that will produce when 25 gram of NaCl reacts completely with what? This. Do you understand? He's just trying to tell us that if 135 gram is produced by 117 gram of, if 135 gram of CuCl2 is produced by 117 gram of NaCl, what mass of CuCl2 will be produced by 25 gram of NaCl? Do you understand? That is just simple. So from here, this is how you calculate this mathematically. Are you getting it? If you cross multiply, you will have something like this. X times 117, right, is equal to 135 times 25, right? So X will be equal to what? 135 times 25 over 117. Am I communicating? X will now be equal to what? 135 times 25. What will it give you? Divided by 117. What will it give you? 28.8 gram. Am I communicating? Now, what does this mean? It simply means that if 25 gram of NaCl react completely, are you getting it? With what? With copper 2 sulfates, 28.8 gram of what? Of copper 2 chloride will be produced. Do you understand? But is this how to present it in your chemistry? No. If you present it this way, this is mathematical presentation. If you present it this way, you fail it, okay? Or the person might not grant you the maximum mark. Do you understand? So how do you solve it to get what? To get your required answer? How do you solve? How do you do it so that you get your? After solving this in your rough book, what you will now do is just to put it in form of statements. Am I communicating? What will you say? 135 gram of copper 2 chloride reacts. 135 gram of copper 2 chloride is produced when 117 gram of sodium chloride reacts completely with what? With copper 2 sulfates. Do you understand? Therefore, mass of copper 2 chloride produced when 25 grams of sodium chloride reacts completely with what? With copper 2 sulfates. I guess it's equals to, you understand? Equals to, you will now write this thing, 135 times 25 over 117 in bracket, you put it in gram, okay? In bracket, gram of what? Of what? Of copper 2 chloride. Do you understand? Therefore, mass of copper 2 chloride produced equal to 28.8 gram. Do you understand? Do you understand? So it's as simple as that. That is how you solve a question like this. Any question? Yes. Now, you are going to, let's talk about another one. No, I want to solve another question. So, as you can see, there's another question. 2.8 moles of hydrochloric acid is poured into a container of sodium triisocarbonate 4. What mass of sodium triisocarbonate 4 would react with the hydrochloric acid? Sorry, would react completely with hydrochloric acid. Very easy. All right. So, what are the two substances we are looking out for? Why? Yeah, they asked us to look for something about sodium triisocarbonate, right? That is Na2CO3. And hydrochloric acid, why? Because they asked us to look for something about it, right? That's what we look for. They gave us 2.8 moles of hydrochloric acid. They gave us something about hydrochloric acid, and they asked us to look for something about sodium triisocarbonate 4. Every other thing that appears here doesn't concern anybody. So Na2CO3 and what again? HCl, right? So what are we considering in Na2CO3? Mass, right? Mass, because they asked us to look for the mass of this, right? Then what about HCl? Moles, right? Yeah, we're looking at the moles, is it not? Now, the next thing is to write the equation, what is present in the equation, right? From the equation, they asked us to look for the mass of this, right? So the mass is what? Okay, they asked us to look for it, right? So it's X, is it not? All right. Now, the number of moles. How do we get the number of moles? Okay, number of moles here. From the equation, they gave us the number of moles of HCl, right? Which will be 2.8. Are you getting it? Now, we'll now go from the equation, right? From the equation of reaction, right? The next one. This one now is from the question that they gave us. This next one now will not be what? The next one we're going to write is the standard relationship. We get the standard relationship from what? From the equation of reaction. So the equation of reaction, look at the equation of reaction here. If this is the equation of reaction, all right, and we are to obtain, now from here we are considering the mass of Na2CO3, right? So we'll go to the equation of reaction and get the mass of Na2CO3, okay? So what is the mass of Na2CO3? From here, we have Na2CO3, right? So we'll use what? Na is what? 23, right? Times 2, right? Plus what? 12, right? C is 12, right? Plus O3 16 times 3. So 23 times 2, 46 plus 12 plus 48. Are you following? So everything, when you add all of them together, it gives you what? I think 106. 46 plus 12, that will give us what? 58. 58 plus 48, that will give us 106. 106 gram. Am I communicating? So from here, what will be here now? What? 106 gram of Na2CO3, right? Now the standard relationship in this HCl, we are no longer considering what? Mass of HCl. We are considering what? Number of moles. So to get the standard number of moles, take note, it is what? It is a number that stands with the what? With the substances. Am I communicating in the equation of reaction? Like here, we have 2 moles of what? 2 moles of what? HCl. We have 1 mole of what? Na2CO3. We have 1 mole of carbon dioxide. We have 1 mole of H2O. We have 2 moles of what? NaCl, right? So, but we are looking at HCl, right? Which is 2 moles, is it not? So that is what will be here. These moles. Now, what does this mean? It's very simple. That means 2 moles of HCl, Abi? 2 moles of what? Of HCl is required to react completely with what? With 106 grams of Na2CO3. Do you understand? Because we are relating what? Moles to mass. Are you getting it? So here we consider moles, here we consider mass. Are you getting it? That means what? 2 moles of what? Or I can say 106 grams of Na2CO3 is required to react completely with what? With 2 moles of what? Of HCl. I hope you are getting it. I hope you are getting it. It's as simple as that. As simple as that. So when you cross multiply from here, if you cross multiply, you have what? 2 times x equal to what? 106 times 2.8, right? So x will be equal to what? 106 times 2.8 over 2, which will give us what? 296.8 over 2, which will give us 148.4 gram, right? Gram of what? Na2CO3, which means mass of Na2CO3 required to react completely with what? With 2.8 moles of hydrochloric acid. I guess is what? 148.4 grams. Do you understand? So in JAMB, if you solve it this way, you are correct, because JAMB is what? Is objective. I guess it. But in WAEC, if you solve this in WAEC like this, you will not get your mark. I guess it. So what do you do? What do you do? It's very simple. You just write it in form of statement. Are you getting it? So they're just saying, you just say 2 moles of what? Of HCl. Are you getting it? Is required to react completely with what? With 106 grams, Abi? Of what? Of Na2CO3. Do you understand? Therefore, 2.8 moles of HCl would be required to react completely with, you will now put this thing that you put here. You understand? With what? 106 times 2.8 over 2 in brackets gram, Abi? Of what? Of Na2CO3. Do you understand? Therefore, any mass of Na2CO3 reacted or required equals to what? 148.4 grams. Do you understand? It's as simple as that. Any question? So, we can see another question. Calcium hydroxide. So what number of moles of ammonia gas would be evolved when 7.8 moles of calcium hydroxide react completely with ammonium chloride? So the two things we are looking out for: what number of moles of ammonia gas would be evolved when what number of moles of ammonia gas? So one of the substances we are looking out for is ammonia gas. Do you understand? Ammonia gas. So NH3. Are you getting it? Do you understand? Would be evolved when 7.8 moles of calcium hydroxide. Calcium hydroxide is another substance that we are looking out for. Okay? So so yes, what number of moles? That means we are considering moles of what? Ammonia gas. What number of moles of ammonia gas would be evolved when 7.8 moles? We are still considering moles, Abi? Number of moles. So from here we have what? Ammonia gas. Ammonia gas. So we are looking for this, right? That is X, right? Alright. Calcium hydroxide, we have 1, right? Then for ammonia gas, it is 2, right? Then for calcium hydroxide, alright? Sorry. Yes. They gave us, this one is what they gave us, right? Which will be 7.8, is it not? Then this one will not be what? 2, right? Because from the equation of reaction, we have what? 2 moles of what? Ammonia gas, right? And then we have what? 1, right? 1 mole here. Which will now be, if you cross multiply, you have what? X times 1 equal to what? 2 times 7.8, right? So X equal to what? 2 times 7, that is 15.6 moles. Are you getting it? So it simply means that 15.6 moles of ammonia gas will be produced when what? When 7.8 moles of what? Calcium hydroxide reacts completely with what? Ammonium chloride. So what you are trying to say, what you say is that what? 2 moles of what? Ammonia gas reacts completely. Is produced when what? When 1 mole of what? Of calcium hydroxide reacts completely with what? With sodium chloride. Therefore, 7.8 moles of calcium hydroxide will react completely with what? Ammonium chloride to produce 2 times 7.8 moles of what? Of ammonia gas. Therefore, number of moles of ammonia gas that is what? That is produced is what? 15.6 moles. Right? So in our next class, we are going to try to find how we can inculcate the volume and number of substances. Thank you very much.